Welcome back to the Health Physics Society's video series pursuing the truth and promoting transparency regarding the historical foundations of the current radiation protection philosophy based on a linear no-threshold theory for cancer risk assessment. I'm Dr. John Cardarelli, President of the Health Physics Society. In the first episode, we learned about Dr. Calabrese and his introduction into the field of toxicology and involvement within the environmental movement. We'll pick up from there and take a step back in time to the early 20th century to learn about the origin of the linear no-threshold theory, the people involved, and what was driving them to do this research.
As the US EPA went, the rest of the world went. And so when you look at other countries around the world, regardless of the continent, they really look first to the US, and historically have looked first, even though there is a desire to be somewhat independent, intellectually independent. The leadership, especially during the formative stages of the environmental movement, so to speak, it was really the US leading the way.
And where did the model originate? How did this become the model that was used?
Well, the model originates from a very obscure beginning, surprisingly. I mean, I thought it was, crystallized by the greatest toxicologist in the world. And actually it was not. It was a model that was formulated not to be applied to, or certainly was not being applied to risk assessment, cancer risk assessment, or any risk assessment in general. And the reason why it wasn't because it didn't have application. It was because the model was first proposed for use, believe it or not, well before I was born in 1928. And it was put forward by a couple of, not toxicologists, but the University of California at Berkeley, a couple of physical chemists. And one of those physical chemists was extremely prominent person, and his name was Gilbert Lewis. And Gilbert Lewis was famous, if you take a lot of chemistry classes in college, there are such things as Lewis acids and bases, and they're really named after this prominent man. And what happened was that they were reading the literature, and they saw that in 1927 there was a major paper that was published that was first paper ever to be able to induce gene mutation in any sort of a biological system. And it was published by a professor at the University of Indiana by the name of Hermann Muller. And so back in the day, Muller was really going after mutation, and he was in a race with others to be the first to induce mutation, but they really weren't trying to prove that there was an association between mutation and cancer. They were really trying to figure out the mechanism of what? The mechanism of evolution. And evolution was like the major question, and how it came to be back in the first decades of the 1900s anyways. I mean, coming after Darwin with his book in 1865, and then Gregor Mendel with regards to genetic separation of traits and so forth. They're really looking at, well, how did these changes, biological changes, take place? And they knew that they were genes and they were located on chromosomes, but how did it actually take place? And there was a race to figure this out, and Muller was in that race. And when he was a graduate student at Columbia, and that race started around 1910. And I can tell you, when he was at Columbia, his professor and the other graduate students, they threw everything at their little fruit fly Drosophila except the kitchen sink. They hit that Drosophila with radon, with X-rays. They hit it with
chemicals as well?
The most toxic chemicals that they could find, they used. And the interesting thing is, regardless of the dosing that they did or the agents that they applied and how they did it, they were unable to induce mutation in this fruit fly. And this went on for year after year after year. And these were very bright people. And Muller's advisor himself would get a Nobel Prize in 1933 in terms of the structure of genes and chromosomes. And Muller would ultimately, he would have his own day in the sun a number of years later. But this brainy group of graduate students and his advisor, Thomas Hunt Morgan. They were unsuccessful for a long time. And then what happens is that Muller breaks through, and we'll go into that in some detail a little bit later. But what happened is that this group out in California, they see the paper, and they seize upon it. And they propose that, wow, that how we think evolution came to be was through mutation, and it came through cosmic and terrestrial radiation that was hitting the Earth and organisms at some relatively low level, but constant level, and that we believe that's me characterizing what they wrote in their 1928 paper in the journal Nature, that in fact that cosmic radiation and terrestrial radiation was the cause, the mechanism of evolution, and it was due to mutation, and they laid that right out there in the journal Nature. And they had to assume that there was a linear dose response for this to apply to all organisms. And that's where the thought initially comes from.
So that is a fascinating story. When they looked for mutations, were they looking at the future generations of these fruit flies, so they would breed them and then be able to identify something in the phenotype or genotype? How are they identifying the mutations?
The simplest and most direct was a visual approach. And they were using what they call sex-linked recessive techniques. And what they were really trying to do was to cause a mutation in the X chromosome that would result in lethality in the next generation. And since the male only has one full-sized X chromosome, it becomes, as in the case of humans, males are much more susceptible to, let's say, sex-linked traits than the female, and would have problems with having higher color blindness or other types of traits. And so if you did their kind of work, you would see that the death to the next generation, because they were looking at lethality mutations, would be much more evident in the male than in the female. And so it was almost a treat them and then count them sort of an activity. But nonetheless, it was dealing with a very profound issue of gene mutation and then seeing something take place in the next generation.
I see. So the hypothesis then was that the natural background radiation, the cosmic rays, the radon, would induce these small mutations in the population, and that is how evolution occurred. Was that what Dr. Muller was using? Low-level background radiation?
Actually, just the opposite. Muller approached his research, even though he was very interested in this evolution question. He was going for the evolution question. He was going for the Nobel Prize himself. I mean, everybody who was top draw was going for that Nobel Prize. And I'd have to say Gilbert Lewis, that proposed that LNT plan. Gilbert Lewis was a top scientist. Gilbert Lewis himself in the area of chemistry was nominated 42 times for a Nobel Prize and never got it. Mostly from the stories that I have read and dug into on him was in fact because there was a person on the Nobel Prize awarding committee that had a personal conflict with him and would block the votes for Gilbert Lewis. And but Lewis was a big time player, but he was stepping out of his field. He was he's a big time physical chemist, and he's trying to become more of a biologist and applying his thoughts across boundaries. And biology is really quite a bit different than working in the physical sciences. I'd say Gilbert Lewis had speculated about 3 years earlier in a lecture at Yale called the Silliman Lecture, named after a very famous scientist back in the 1700s, early 1800s. And and he made speculation about the mechanisms of evolution. And so that when his paper came out in 1928, if you had been aware of his lecture at Yale, you might not have been that surprised that he was thinking along those terms. But getting back to your question, and that was that when Muller tried to induce gene mutation, well, you have to remember that all they were dealing with in the past was failure. They tried everything to induce gene mutation, and they couldn't do it. And if they were looking at a hot temperature, they made it very hot. If it was a cold temperature, they made it very cold. If it was radiation, it was very radioactive. If it was lead, it was the most lead you could give to a fruit fly short of killing it. They tried everything to induce mutation, and they couldn't do it. And in fact, they knew that it had to be mutation that caused evolution, but they couldn't induce it. And so it's kind of a mystery.
Is it still a mystery today?
Well, not really, but ideas have changed in the sense that they came away with the view that the genome was very stable. It was very hard to induce gene mutation. And so how could they do it? And so Muller, he's a brainy guy, and he's the little engine that never stopped working. And so he continued, and ultimately what he did was he found ways to make his model much more sensitive than the other, you might say, attempts before with his fruit flies. And so as a result of a couple of unique features to his model, which he really didn't know what the implications were, when he applied high levels of ionizing radiation to the model, to his shock, he started seeing a large number of what he interpreted as gene mutations just popping right off, something he had never seen before, and it was just like a little kid in a candy store. He just really got very excited.
And when you say large levels of radiation that he applied, can you give us some comparison?
Yes, I can. Now, this is probably as hard to believe as anything else, because I really can't count too high, but Muller used the lowest dose in his most effective experiment. The lowest dose that he used was approximately 100 million times greater than background. Wow. 100 million. Now his next highest dose was twice that level, so it was 200 million times background. So Muller, when he induced gene mutation in his study, he was giving those animals 100 million times greater than background. And as it turns out, if you want to relate that back to the Gilbert Lewis story, the Gilbert Lewis story is saying evolution is happening by background. And so Muller, in his opening round, major finding, he's induced what he calls gene mutations with a whopping dose. And you might say, well, what happens to a fruit fly when you give 1 million times, 100 million times, not a million. Million would have been a low dose, right? 100 million times greater than background. Well, insects tend to be very resistant compared to mammals to ionizing radiation. However, but even these insects, they didn't like it very much, and most of them became sterilized, and many died. And nonetheless, even though the vast majority of his animals were truly compromised, he was able to squeak out a certain number of effective, because you have a large number. Yeah, and he was able to see these transitions taking place, and he was very excited. And this happened back in November of 1926, and that was when he did his opening round of experiments.
Thank you for watching the second episode on the historical foundations of the linear no threshold theory, where we learned about Gilbert Lewis, Axel Olson, Hermann Muller, Thomas Hunt Morgan, and their pursuit to understand the theory of evolution that brought about the linear no threshold theory. The next episode addresses how Dr. Muller reconciles the differences between his research and Drs. Lewis and Olson. We will explore Muller's rise to prominence in the field and his creation of a scientific revolution in gene mutation theory. The HPS is a trusted source of radiation information. We're a scientific organization, and as is offered with the scientific peer review process, viewers are encouraged to send comments or suggested corrections to factcheck@hps.org, and be sure to include your sources so that we may correct the record if necessary. If any changes are made, they'll appear at the end of this episode. Please visit Ask the Experts web link to ask questions or seek answers to common radiation-related questions, and view our fact sheets. We also have official position statements that can be found on our website at hps.org. Finally, if you wish to join the Home for Radiation Protection Professionals, please visit the link below. We welcome you.